Hello everyone, I'm Jay Joshi and welcome to the 21st episode of Learning Java. Today we'll be learning the searching techniques, how to search for a particular element in an array. So we'll be learning two different types of techniques, linear search and binary search. So both of these searching techniques are methods to search for a particular element in an array, and it can be a singular element or many elements. So first we will be looking into linear search, which is very simple. So, linear search is basically a sequential search technique. What this basically means is we search for a particular element one by one. So, a simple method to do this would be to have a for loop. So, for let's say int I is equal to 0, 0 because the index starts from 0, I should be less than the length of the array and I plus plus. And inside the for loop, we should have an if statement. So, let's say the value we need to search for stored in the variable a. So if a is equal to an array of the ith index, so if a is equal to ar of I, then we can print a message, we found the particular element, and then we can break out of the loop. Otherwise, else it can just continue on with the loop. So this is the basic algorithm of how a linear search works. And you might remember in the sorting technique, we had the selection sort technique. In that also we were using the search technique to search for the smallest or largest element as per the case. So in this case, as I mentioned already, the array is scanned sequentially to locate for a given item or element, and it's compared with the element which the user enters or for which we want to search. So let's have a look at the advantages and disadvantages of linear search. So this method is very easy, as you already know, because you can implement this without even knowing that it's actually linear search. It's a simple and easy technique, and we need not sort the array because it's gonna check for each of the elements. So we need not sort the array. It doesn't work. And even if the array is sorted, it'll work either way. But the disadvantage of linear search is that it's not an ideal method of searching in very big arrays. Let's say we have an array of, let's say, 10,000 elements. We can't, let's say we want to search the element 10. It's an integer array, we want to search for a particular element, and that element is in the final index. So that's the 9,999 index if it's a 10,000 element array. So it'll search from the first element to the last element. Now this will take a very long time because it has to search through all the 10,000 elements. So that's the only disadvantage, and this disadvantage is solved by the binary search technique, which we'll be covering later on. So here's a basic code for the linear search. Now don't get confused by looking at how big of a code this is. Most of it is just like for the data which the user has to input and the ending checking part. The only main part is this much. So first let's see what this code is all about. So first we declare and initialize the scanner. Scanner is equal to new scanner system.in. This will help us accept values from the user. And we declare two variables, int rn and x. And then we declare two arrays, int roll and int math. So to give you a quick background, these are the math marks obtained by the students in the math array. And that's the respective roll number of the students who obtain that math mark. So we ask the user to enter the roll number they want to search for, and the user enters a particular roll number, and if we find that particular roll number, we have to print the math marks of that particular student. So let's say the user enters the roll number 35, so we have to display 52 because that's the math marks obtained by the person of roll number 35. So we accept the roll number which the user enters in the variable rn, and we declare a boolean check which we declare as false, initialize as false. Now, as I mentioned, the for loop, this is where the linear search starts, is x is equal to 0, x should be less than the length of the array, and x plus plus. Now, if, this is the important if statement, if the variable we want to search for is equal to roll number of the 0th index, then we declare check is equal to true, system.out.print math, and then we print the math marks, and then we get out of this loop if we find the particular thing. So if we find the particular roll number, and at the end if check is equal to false, so if we never find the particular roll number, so let's say the user enters 40 and there is no 40 roll number, so it'll never come in this if statement. So towards the end If check is equal to false, then it'll print roll number not found. And this else statement over here, let's say this if is not true, and then we don't even need this else statement because it'll automatically continue with the for loop. But if you want to put continue, you can. That's just making the code unnecessarily long. But I just put it over here to show you the use of break and continue. So this is what basically linear search is. It basically is a for loop and an if inside the for loop. It's nothing very complex. It's just a simple technique. Now we'll be looking into something a bit more complex and useful called binary search. So binary search, as I mentioned already, is the fastest way of searching for a particular element in an array. So in simple terms, it's basically a divide and conquer technique. So what this basically means is, let me give you a quick background of what binary search is. So let's say we have an array with all of these elements. Okay. And just to mention before, this searching technique works only if the array is sorted. Doesn't matter if it's in ascending or descending order, the array should be sorted. So that's the only thing. Before you perform the search technique, the array should be sorted. This is only for binary search. And linear search, the array doesn't have to be sorted. So let's say we have an array and it's an integer array with numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is the entire array. Now let's say we want to search for the element 10. So if this was linear search, it would go from here, then till the end, and it's going to take a while to find out. What binary search is, it's basically like divide and conquer. So what it'll do first, it'll take the middle element of this array. So in this case, the middle element will be this 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. So it can be the 3 or 6. We take it as 3 in this case. So the middle element, which is 5 over here. Now, first it assumes the middle element to be 5 because it is the middle element. And if it checks, then if the particular number we are searching for is less than 5 or greater than 5. So if the number in this case, it's greater than 5. So then it assumes the middle element to be this 8. And it forgets this part of the entire array because we know that the number is greater than 5. This means it greater than 5. So it can't be 5 as well. So it's either it's not in this, it's in the other half, the right half of the array, the greater half of the array. So it assumes this to be the middle element now of the rest of the array. And then it again checks if the number we are searching for is greater than the middle element or less than the middle element. In this case, it's again greater. So we know that it's neither this number because it's not equal to that number, and it's neither number before that. Then it assumes this to be the middle number because this is the middle element. And in this case, it is the middle element, which is what we are searching for. So we found out so early in like 3 steps. So first this middle element, second and third. In 3 steps, we found out which if the particular element is in the particular array or not. But had it been linear search, we would have to wait for 11 iterations for it to find out. And let's say the number we were searching for was 11, then it would be greater than 10. So we know that's not this, and then it's this. So this is what binary search is. It's the fastest method of searching for a particular element in an array, but the array has to be sorted in either ascending or descending order. And this method of searching is ideal for large arrays. If you have a very small array, you can just use linear search, but if you have a very large array, then you have to use binary search. So I already explained the algorithm. Let's say we have an array in the ascending order. So it compares the particular element which the user wants to search for with the middle element. So, and the array keeps on changing. So if it's smaller, then on the left half of the array, large on the right half. Then if it's smaller, then the array size just keeps on shrinking. So what we are doing is the comparison part, we are just making the array smaller at each step. And this process keeps on getting repeated till the element is found. And if it's not, that means the particular element was not found in the array. So let me show you the code for binary search. We have the normal class and scanner CV declare. This is the same roll number marks thing, only the values are a bit different. So we have int r for this array for the roll numbers, marks for the marks obtained by each of those respective roll numbers. We ask the user to enter the roll number and we store the number which the user enters in the variable n. We have the boolean chk, which is false. We declare it as false always. And now this entire part is the part for binary search. So let's understand this properly. So in each case, whenever we have a middle element, we are shrinking the array, right? So we need a element, the least value of the element. So let's say we have an array of 10, like in this case of length 10. So when we divide it into half, so there are two parts of the array, phi and phi. And we find out that the element is on the right half. So it's between either phi and 10, element phi and 10. So the lower limit of the array will become phi and the upper limit will become 10. But if it was in the smaller half on the left side, the element will either be between 0 and phi. So the lower limit will become 0 and then phi. And then let's say 0, phi, and then we find the middle element to be 3. Then again, and it's again in the lower half, then it's again 0 and between 0 and 3. So lower limit is 0, upper limit is 3. So this is the lower limit variable, this is the upper limit variable, and this is the middle variable. So at the beginning, we just declare the int m is equal to 0. We don't need to put any value. But the lower limit, so currently the entire array is full. So the lower limit will obviously be 0, the 0th element. And the upper limit will be the final element, which will be r.length minus 1, because it's the final index of that particular element, of that particular array. Now we look at the while loop. So there's only one loop in this, and there are just if statements inside this. So the while condition is the most important. If length is the lower limit, is less than equal to the upper limit. So if the lower limit becomes greater than the upper limit, which we'll see an example of, then we get out of the while loop, which means that the element hasn't been found. So then as soon as we enter the while loop, let's say this is the first iteration, we calculate the middle element. So since this is an integer, the middle element value will always be an integer. So it's going to be lower limit plus upper limit divided by 2. So lower limit over is 0 and r.length will be 10 because the length is 10 minus 1. So that's 9. So 0 plus 9 is 9 divided by 2, which is actually 4.5. But since it's integer, it will be 4. So the middle value is 4. Right now, that's the index. So 4. Then like linear search, we just check, use the normal if statement. If the middle element, the roll number of the middle element is the same as that of what the user wants us to search for. So if we check if the roll number at the middle index is the same as that of the value which the user entered. If it is, then well and good, check is equal to true. And then break, and over here we see if check is true, then we print the marks of that particular student, otherwise roll number not found. So, and then we break if we find that element. But if we don't, here comes the important part. We have an else if and an else statement. So if it's not the middle element, the element can either be less than the middle element or greater than the middle element. So if the element is less, so if the element we are searching for is greater than the middle element, so in this case, this is the roll number we are searching for, and this is the roll number in the middle place. So if the particular roll number we are searching for is greater than the middle element, the roll number at the middle element, we make the upper limit one more than the middle element. Why? Because we know that the roll number is greater than the middle element and it's not the middle element. So since it's greater than the middle element and not the middle element, the index from which it's possible that the element is, it's one more than m. So this condition is only if it's if the element is greater. But if the element is less than the middle element, we know that it's neither the middle element nor anything greater than that. So the upper limit will change this time. So the lower limit will remain 0 and the upper limit will become 1 less than the middle element, which will be 3 in this case because middle element was 4. So just for a recall again, if the number is greater, what we are searching for, the upper limit will remain the same and the lower limit will become 1 greater than the upper limit, which will be 1 greater than the middle element, which will be 5 because it was 4, and it'll be vice versa as I mentioned in the other case. So this is the basic process, and this process keeps on going on, and later on if you'll never find the thing, then the lower limit will become greater than the upper limit. That's how it is. So let's check if this code actually works. So let me just check. So these are all the roll numbers and these are the respective marks obtained. So I made it in a simple way. So it asks me to enter the roll number. Let's say I enter 7 and it tells 70. So, but let's say if I enter the roll number, let's say 15, which doesn't exist. So roll number not found. So this is what binary search is. Now coming back to the PPT, I have this another example to understand the concept better. Here's another array of length 9 and index from 0 to 8. We are searching for the number 23, which is over here as you can see. We are searching for the number at the 7th index. And so the output over here should be 7 because the number you're searching for is 7. So the lower limit over here is 0 at the beginning and the upper limit is 8 because it's 1 less than the length. And the middle will be lower plus upper divide by 2, which will be 4. So this is the middle in blue, lower limit in green, upper limit in red. Now it checks the if condition if it's equal to if the middle roll number, so if not roll number, if the particular number 13, so the value at the 4th index, if 13 is equal to 23, it's not, then it checks if it's lesser or greater. So in this case it's greater, so 23 is greater than 13. So the lower limit will become 1 greater than the middle element. So the lower limit will become 1 plus m, which will become 5, and the upper limit will remain 8. So now we go to step 2 and we can see that the lower limit is 19, which is the 5th index, and the upper limit is 29, is the 8th index, which is 29. So you know that the number is either of these two or the middle, or the number between these two. So the middle element will become lower limit plus upper limit 13 with divide by 2, which is 6. It won't be 6.5 because it's integer, so it rounds off to 6, lower number. So it'll be the 6th index, so 20 is the middle element, and it checks if 20 with the middle element is equal to the number, which it's not in this case. So it checks if it's lesser or greater. In this case it's greater, so the lower limit will become 1 plus the middle element. So the lower limit over here will become 1 greater than the middle element, which will be 7, and the upper limit remains as is, which is 8. So now the middle element will be 7 plus 8 divided by 2, so the middle element will become 7. So the middle element and the lower element have the same index over here, so it checks if the middle element value is the same as that of the number, which it is because it's 7, so the output comes 7, and we have searched for the number successfully. Now let's say the number we were searching for was 40, example, so which is not in the array. So let's see how it's going to get terminated. So middle element was 7, the 7th index, and it checks if 23 is equal to 40. The previous steps are remaining the same because it's greater. So it checks if 23 is equal to 40, which it's not. So it checks if it's greater. So it is greater than the middle element. So the lower limit becomes 8 and the upper limit remains as is, which is 8. So the middle element this time becomes 8 plus 8, 16 divided by 2 is 8 as well. So again, 29 is not equal to 40. So it checks if it's lesser or greater. Since it's greater, the lower limit will become 1 more than the middle element, 9, and the upper limit will become 8. And so you can see that the lower limit has become greater than the upper limit, and we had the condition in the while loop, L should be less than equal to U, and this condition has now become false, so it's going to come out of the loop, and thus we have not found that particular element. So this is the basic dry run of the binary search. So I would recommend you all try to write the code on your own. Don't just copy it directly. Try to write the code on your own, understand the code, and then practice with it, experiment with it. There are other searching techniques as well, but I'll be covering them in a later video. Again, linear search you can use for small codes, but binary search is for big codes because it's a faster technique. So that's it for today, everyone. Thanks for watching, and if you have any queries, doubts, or suggestions, you can mail me. My email will be in the description down below, and thanks again for watching.